Hi guys, this video today we're going to talk about how to graph or what the graph is going to look like if we were going to graph the displacement over time of a pendulum. So we know, I have a little diagram here, we know that if we have a pendulum it's going back and forth and back and forth and back and forth. And it is going in a rhythmic pattern, it has simple harmonic motion, and it's going to go from point A to point B, like it's going to go back and forth horizontally. Now, of course, it has a bit of a curve to it when it goes, but right now we're just looking at how far horizontally is it going. We have a formula that tells us how far it's going horizontally, and this formula is x equals, x being the horizontal distance, a times the cosine of 2 pi, and remember that's just a pi, I couldn't get that in my font, but that's a pi. And F stands for the frequency and T stands for the time, and by time I mean like the time after you've let it go. Okay. Another thing to think about with pendulums is we have a point that's called an equilibrium point. And the equilibrium point is when it is straight up and down. That's called your equilibrium point. It's called the equilibrium point because it is in the middle. It is where if this did stop swinging, it would stop right there, right? So that's our equilibrium point. And so it's going back and forth and back and forth. X is our distance from the equilibrium point. A is the amplitude, and that basically means like how far did you pull it back to start with? That's going to give us our amplitude. And then we have the rest of this. F is frequency and T is time. And by time, I mean, like if this is time 0, then after how many seconds does it go to a certain place and stop there? That is our time, not the capital T, which is the period. Now, going back to frequency though, frequency is 1 over the period. And so we know that. And so in this case, this is our period, so it's going to be 1 over this. We're going to have to do some work here to get to our starting point. Let's take a look at the actual problem. A pendulum on Earth has a length of 1 meter and an amplitude of 10 centimeters, which is 0.1 of a meter. Fill in the table below for the horizontal displacement at various times. Please make sure your calculator is in radian mode for this. So we have our time over here, which of course is t. We have our horizontal displacement, which is x, and this is the x I'm talking about. So we're going to have to do this formula to fill in this box. Okay, do we have enough information yet? Not really. Okay, T is over here, so we're okay on that. F we are missing. And A we are given, so that's good. We need to find F though, and that's where this part of the calculations comes into play. So we're going to do this. I'm going to plug in what we do know. So we keep our 2 pi. It is 1 meter, that's a meter, 1 meter over 9.8 meters per second squared. Take a second on your calculator and see what you get for that. Okay, when you plug that in, you should get something close to 0.5, depending on if you use 9.8 or 10. Either way, though, it basically is 0.5 hertz. So that is our frequency. We need that for this formula. And I've kind of run out of space, so I'm going to come down here. So the x, which is going to go into our y column, is going to be equal to a, which in this case is 0.1 meter, times the cosine of 2 pi times the frequency, which is 0.5, times the t, which is the x column. And so this actually can be simplified even further, right? And so the 0.5 and the 2, that just gives us a 1. And so I've rewritten this a little bit easier. X equals 1.1 meter, 1/10 of a meter, times the cosine of pi times t. And so now we can put this into our calculator, and we have two options. We can go step by step and plug in a 0, see what we get, plug in a 0.2, see what we get, and so forth and so on. Or we could go into our y equals button and put it in there. Also, at the top, there's an important note that this is in radian mode. So let's go to our calculators. We're going to go to radian mode, and we're going to put this into the y equals so that we can just come up with a table. Okay, first of all, in your calculator, go to the mode button, which is here. Go down to, oh, and I'm already in radians. Okay, so we're going to go down radians. Okay, once you are in radians, just quit this. So go to second quit to get out. And then we're going to go to the y equals. And we are going to put in that equation that we had. That was 0.1 times the cosine of pi times x. Okay, once we get that into our y equals, first step I want to do is look at the table. So to go to the table, you go to second table. And because the table, well, my table is way off, and the table we have on our paper counts by 2/10 of a second. So let's go to table setup. That's this button here. Go to second, table setup. Let's start at 0 and let's count by 0.2 because that's what it is on the paper. And then let's go back to the table. So second table. Okay. At 0, we're at 0.1. That means 10 centimeters. And then 0.0809, 0.0309, etc., etc. On our paper, it says in centimeters. So let's actually move over 2 decimal places for this and then write this down on our paper. Okay, so this is what you should have in your table at this point. Next, we are going to graph it. So let's go to the bottom page and look at the graph, and let's set up our axes, what we need to set up. Our time needs to go up to 2 seconds, and our horizontal displacement needs to go from 10 centimeters to negative 10 centimeters, which is here, 10 to negative 10 centimeters. So if I set up my graph, here's how I want to set up the graph. Take a second to do this. I'm counting my 0.2s because that's what my table is counting by, and I go all the way up to 2 seconds. On my y-axis, I'm going from negative 10 to 0 to positive 10. So take a second, you might need to pause it and set up that table, or excuse me, those axes. Okay, once you have set up your axes, now take a minute to plot these points. So I'm just plotting every point. 0 is at 10, 0.2 was at 8, 8.08, 8.09, it's pretty close to 8. 0.4 was at 3.09, again pretty close. So just take a minute to start putting those points on there. Okay, once you have your points on there, once you connect them with a nice curve, you should notice that this is a cosine function. Some of you maybe are still in Algebra 2, and if you're still in Algebra 2, you haven't learned how to graph these yet. Hopefully we will get to that this year, but this is a cosine function. This is what it looks like. And that makes sense because our function that we entered into our calculator was a cosine function. And so this is what the cosine function looks like. And that is the pattern that the displacement is going to have. The horizontal displacement is going to look like this. It is going to look like a cosine function with respect to time. And if you think about that again, you have this pendulum. And you start the pendulum over here, let's say 10 centimeters away, and it goes back to the negative 10, back to the positive 10, back to the negative 10, and so forth and so on. And so as this is going, this is the curve that it's going to create.